I'm Mizan. I'm from Bangladesh, so you already know about it. So let's go through the most known, or what should I say, most used word in current technology trend, the DevOps. So what is actually DevOps to you guys? Anyone here who's actually playing the role of DevOps engineer or being part of a DevOps team? No one? Someone there, great. Sleeping, huh? Saidurva, yeah, okay. So, great. So what is actually DevOps? So as the description goes, a culture and mindset for collaboration between developer and operations. And what we do, we actually see some picture like this. There's the intersection between development, quality assurance, and IT operations. So most of the presentation, most of the online articles will tell you this is DevOps, right? Unfortunately, this is not DevOps. So just to give you an example, have you ever seen such a football match or cricket match where it happens is that national team playing with World 11? The best players in the world come to play for as a one team, and they're playing with another country. Did you realize how many times the World 11 won? Most of them, they are the losing side. What's the reason? They're the best players from different countries, They're playing in the same team, they should be winning all the time. Because the country can't produce, all the top players in the world. But they're losing. The reason is the collaboration and the understanding is missing over there. You just can't pick some people, form a team and say, okay, now we have one of the best team. And that's actually what we are doing at this moment in DevOps part. That we are actually putting a separate team where we actually create the operations part with a new name, that okay, this is DevOps. And we try to actually get successful or achieve success through that practice where there is no collaboration, there is no cultural mindset that we will be working in a collaborative way. And what we do most of the time, if we look at this as a whole DevOps cycle, we call it a cycle and it's actually a continuous cycle, that we want to actually have a smooth operation so that our customer can have better experience. And the whole plan is that you plan something, you code, you build, you test, so you're done with the development part. And then the operations part takes over. The release, deploy, operate, and monitor. And the concept that we are talking about is almost like 10 years old. So since 2008 to 2018. So DevOps is almost, kind of like for a few of the companies, is a dying concept because there are some overlaps and confusion as well. And most of the time, we are actually ending up in the confusion state that what is actually DevOps. So what we do, so most of the time in the companies, we are ending up DevOps concept as a tool-based concept, right? Like we are using some tools, we are coming up with some fancy softwares or applications, and we are saying that, okay, we are DevOps. Or we might have a team, like the DevOps team. And we have roles called DevOps engineer. It's like, something like having an engineer to actually manage the culture or enforce the culture, which we really can't do. So the DevOps principle says that there are 3 ways: system thinking, that you have to think, in a systematic way; amplify feedback loops. Whatever you're doing, try to get feedback as much as possible. And, that always has to be in a continuous way. It's not like, okay, I take feedback from a certain, event or certain way, and I forget about it. You should be always in a continuous way. And then culture of continual experimentation. So whatever we do, we have to actually do the experimentation. Another principle is we call it CAMS, where we say culture, automation, measurement, and sharing. The problem with the DevOps is that at current world, we are more focused on the tools. So if you talk about DevOps, anyone, and they will give you a list of tools, and that's what I'm going to do. The tools, and practices. So we saw the 7 steps previously, right? Plan, code, build, test, the total 8, release, deploy, operate, and monitor. So what are the tools we can actually use in these steps? So just to ask you guys question, what are the planning software you guys use at your organization at this moment? Jira, good. Anything else? Trello? So there are many tools. How many of you guys actually use Wiki? Good, at least one. So 2. So now we'll actually talk about the tools. So before going to the tools, my topic says that tools and practices. Why we really need to have that discussion. Now, this is a famous, agile diagram. We call it quadrants. In many of the topics, you'll see this diagram, coming. So, especially in agile engineering talks, we usually use this diagram. So this one is actually my build, so I'm not sure about how much correct it is. So if there's a mistake, you can actually correct me. So this is a quadrant where I tried to show why we should use the right tool and right practices. So if we have the right tools and have the right practices, then definitely we are going to have, the success that you are looking for, building better software, and also have the control. Now, if we have the right practices but the wrong tool, then what will happen? We'll have issues with maintaining the whole process, the release process, the maintenance, and everything. And what about the wrong tool and wrong practices? Like, I don't have the tool, and I don't know the practice, or I don't want to. That's actually the failed opportunity that you could have done much better. Then again, I have right tools, but wrong practices. Like if I give you Wiki, and you don't write anything over there, you just put some notes over there or copy your email over there, that's actually not the purpose of Wiki. So these sort of things are actually happening. So we are not actually using the right tools, and definitely not the right practices. Just to give you an example, there are lots of companies working around the world who doesn't have documentation, like especially when you are building microservices, talking about agile ways of working. And when I ask them, how do you actually share in between teams that whatever you are building? And they're like, okay, we just send them an email that, okay, why don't you find it out? Or maybe a dump of our favorite, the API tool, Swagger or something like that. So what in my organization and we do is that whenever you are building an API, the first thing you have to do, you have to prepare a wiki doc with all the necessary information. What are the parameters is required? What are the authentication method you are using? What is the API key? Which IP address the staging server is, the production server is, everything. Then you share it with the team. Now, team member can go and integrate it. QA team can go and test it. But that wiki document is there for everyone. Now, if I have to give it to someone, another team, the document is there. So we are actually saving time by doing the simple approach. So it's always important that we choose the right tools and the right practices. That should be our target. Now, as we said, we have 8 different steps. Now we are going to go through some of the long list of tools what you can use, and I would like to know your feedback, like which of the tools you guys are actually using. How many of you are using Jira? Paid tool. Wow, that's a lot of users. That's good to see, because Jira is paid, and many of us actually don't like Jira because why do we pay? We are open source and free software users. Wiki, very less, but you should be actually Wiki should be more popular to the engineering teams because that's one of the tools we really use. I didn't say blog because blog and Wiki are different, so you should not write blog in Wiki, like especially in Confluence. So why do you use Wiki? Because it's editable by anyone. Anyone can edit, and we can actually go through the history of Wiki to see who's done what. So technical documentation, requirement, everything can be in Wiki. Now, if you are not, affording Jira, you just following Kanban or having a simple to-do list, you can go with Trello. It's more than good enough. It's just a plan how to do things. Slack. So Slack is kind of like it became the default, developers communications tool. So instead of Skype, instead of email, we prefer Slack. It's much better. Then there are other tools like Redmine, Track, Rally, whatever you guys use, you guys have to actually ensure that you are using a proper tool for planning. Now, most of the tools are either open source, there are tools like free, there are tools like enterprise level. So it's based on pricing and your need, you have to choose the right tool. Sometimes it happens is that I know this is the best tool, but in terms of pricing and everything, it doesn't suit the need. Then code. Is there anyone in the audience who is an engineer and not using a IDE or haven't heard about IDE? Kapil bhai, how come? VI. Then you are the better programmer, VI programmer, huh? Vim. So there's a joke like, how to know you are a Unix programmer or you know at Unix. Just open Vim and tell them to quit. So that's actually the toughest thing. Yeah, that's actually will show you how much Unix command you know. So basically, if you are a developer and developing something, you will definitely use IDE. So integrated development environment. If you are not using it, you must use it. It's not only just IntelliSense or something like that. It's one of the best tools you can actually use. So if you are a .NET programmer, go for Visual Studio. Then the VS Code is there. We have NetBeans. We have some other tools like Eclipse. Yeah, so NetBeans we use. So JetBrains and the Eclipse is there. And we must use VCS or visual, version control system. So how many of you guys are using any version control system? I can see a few of the hands they are not using. So nobody uses Git or Subversion? Good, because I do not want to see anyone who's following Agile and still managing their versions manually. It will be good if you can manage, but that will be a nightmare to actually do. So just to give an example, one of my project I did last year, so one of my clients actually gave me a work like, Mizan, we are really struggling with the project, can you actually see? So I said, okay, send me over. And it was a cake PHP project with almost close to 1 gigs of source code. So I told him like, what the hell did you did? 1 gigs of source code, that must be, like the biggest PHP project ever I have seen. Then I opened the file, good, unzipped it. So I went to the CSS folder, there's a one called style.css, have around 10,000 version. I was like, what? I was like, yeah, this is how they did the version control. So in the year 2017, if people are doing that, that means we are actually not using the right tool. So use Git, one of the best tools you can have. Now, build. So if you want to build, so how many of you are actually building your solutions? I know in Nepal, there are lots of PHP programmers, right? So in PHP, what do you use for build? Do you use anything for building? Is it required to build anything? We are not worried about containers, just a general application. So that's pooling. So usually, actually, we don't need to build something in PHP, actually. It runs automatically. But if you're using Java or, say, C# or .NET, then definitely we need a build tools. So there are lots of build tools. Apache Maven is one such tool, very easy to use. A single command tool, you create the Maven file, and anywhere you download, just run it, the POM file, and it will start building the whole project. Then we have, make the command one from, that's actually a default one that you can actually use in Unix and Linux environment. If you are up to paid software, you can use TeamCity. They do the building automatically, or you can use MS Build, the Microsoft one. Then Visual Studio has it built in, Travis CI. So most of the CI server, the continuous integration servers, they have the build tool integrated. So use one of them, and one of the point that we'll be seeing such screen a lot, but that doesn't mean that you have to use all the tools. So each of the tools is actually doing the same thing, but based on your platform, based on your technology, choice, you are going to choose the right one. Like if you are using Gulp, that's the one of the latest one. If you are building, having lots of Node.js application or JS-based application, Gulp can be a good one. Then test. How many of you actually test your codes? Developers? And QA engineers? What are the tools that you guys actually mainly follow? Selenium? Okay, JMeter. APM? No one uses APM, so how do you test your mobile apps? That's good. So there are lots of good framework like, tools like APM is there, there is robot framework, fitness is there. Then we use JMeter for what? Performance and load testing. Then we have JUnit for unit testing. How many of you use actually unit testing in development? Very less hand, that should be more. So if you're a developer and if you're not performing the unit testing, then definitely something is wrong. So what we do, in many of the companies, the QA team are almost equal almost equal size of the development team. What's the reason? My job is to write the code, and your job is to test it. It's like, whatever I can do in the code, someone has to catch it. And if it's not catched, it's going to production with that, the blame goes to QA. It's not my mistake. So that should not be a practice. You should be always focused on quality code. And one thing Agile always says that we do not compromise with quality. So quality should be intact. We should reduce our deliverables if required, if we have to give more time for quality, but we should not focus on more deliveries and low quality. So you should always test your code. As a developer, you should be focusing more on unit testing. You should be more focusing on BDD-driven approach so that not only your particular unit code is working, but your whole behavior, that is the acceptance criteria, is also matched. So there are lots of good tools like unit test. Here is actually we have produced everything. Another tool is like Selenium, that's quite popular if you're doing an UI-based testing. Selenium is, I think, one of the best and most popular tool in the world. Then release, none of them actually very familiar. So usually what we do is that, is there anyone who is using release management software here? We do CI/CD, but we actually don't use a deep level released software. Now, release is important. The reason because is that I believe after the last session, someone asked me like, someone is doing release at the very end, not after every sprint, whether it's correct or not. That's correct. The problem is that the release should be decided based on the need of the company. Like for example, we like CI/CD. The reason is that whenever someone is committed some code, it's going to production immediately. I just can't do that with all the solutions. Say if I have a banking software, or say NASA, they're building some software, they just can't release immediately. There has to be a release cycle. Say there are some companies who prefer nightly builds, every night one release. There are companies who does it every week, every month, maybe every quarter, or there might be some dates, pre-decided dates that on this date we are actually releasing it. So for release one, we really don't want to actually, if we are not in CI/CD, that doesn't mean that we are not following Agile. The release cycle has to be maintained separately. And that's actually based on the discussion of the product owners, the company, the stakeholders and everyone. So release tools are actually doing that when the release will go on, how to manage the, the releasable items, what will be the release notes, and who will be notified. So this sort of works are done through the release management software. Xavier Labs are having some good tools. The Plutora is one of the open source tools we have. Then deploy. We built, we are planning to release, now we need to deploy. There are tons of deployment tools. And when we say deployment, most of the tools are actually part of CI, the continuous integration. So whether you have heard about Travis CI, Circle CI, then we have, Gump, we have Hudson. So anyone heard about Hudson? It's not the river Hudson. So Hudson is actually the old name of Jenkins. So Jenkins' old name is Hudson. So Hudson is the actual project of called Jenkins. So Hudson became Jenkins when it came to open source. Before that, it was Hudson itself. So Jenkins is one of the most popular deployment tool we have at this moment. And Capistrano you can use if you want to have more control. If you have used Jenkins, you will see that it's more like the UI is not that, doesn't look professional, but the good important part is that it works. That's actually the main thing, and one of the most flexible tool you can use. You name anything you need, it must have a plugin. Say, for example, if you're working on .NET or Java, PHP, JavaScript, Node.js, everything, all the support it has, whether it's test-driven development, BDD, whatever you want to, use, you can use with the Jenkins, and everything pluggable. So you don't have to install thousands of items just to make one thing work. Whatever you need, you add it, else you remove it. Actually, in this session, I had a plan to actually show you the Jenkins flow, but unfortunately, that has to change. Now, monitoring. So once we release, the whole process says that you just deploy it, now you have to monitor, because if you don't monitor, what will happen? There might be issues. And how many times it happened with you guys that your service is down, you guys don't know, but your customer knows? Never happened to anyone? That you don't know that your service is down, but your customer knows that service is down, and you got a mail that, okay, my service is down. But there is a bug, it's not working. So monitoring actually helps us in that way. So if you are actually using, microservice architecture, if you are actually going to Agile architecture part, monitoring becomes more, much more important, because at that moment we have multiple servers or multiple services running in different containers, different places, and there can be issues that one container cannot connect to another container. So their intercommunication is hampering. So there are so many tools for that, and usually we use Nagios. That's another tool, very simple. Then we have Pingdom. So it's just like you ping and see whether the service is alive or not. If not, do some alert. And lots of tools are there. There are like Sentries there, Grafana. And as I said, like the tools you will pick is not actually what others are using, is actually based on your compatibility, whether it fits your company needs, your project needs, budget, and everything. And other tools like, for example, the provisioning. So when we are talking about DevOps culture, we are actually also promoting the provisioning part. Like you should not release everything immediately. You should have some sort of provisioning so that you can actually check, then make a decision, then release. And we also do the version control, you already talked about it, the configuration management. So when you are saying the provisioning, usually we have multiple instances. So for example, an ideal scenario for current DevOps practice should be there will be a separate servers for developers where we can actually do whatever we want to do, crash it, update a incomplete feature, whatever you want to do it. Staging, close to near production, so that it actually gives us an idea how it's gonna work in production, or waiting release features going to be in staging. Then the production. Now, how many of you actually test in production? The real life testing. Like I don't have any staging, I don't have any dev, so whatever I do, I have to do it in production. So usually we do that, and that's actually something a bad thing. Now when we have multiple provisioning or multiple different cluster of services or servers, how do I actually manage the configuration? How do I change, like, okay, which database is going to connect, which file is going to write the log, what will be the URL of this? So everything actually we do through configuration management. We use either Puppet or Chef. So these sort of tools, what they do is that we configure them for this particular set of servers. We are going to use this database or this file for log, or this Redis server, or this URL, this API with this authentication key, and we keep it in a simple configurable file. So when we are using CI and CD, we can use our Jenkins or any other tool to actually pull those configuration and put it in the configurable file. So that does automatically. So that's actually one of the practices that DevOps should do. Then other tools like the feedback part. So as I said, like the whole process is to actually amplify the feedback. And you can use any tool you want to use. So Pendo is one of the tools that actually focus on the feedback part. There's a FlowDoc, HotSuite. You can do Slack. You can do Jira Service Desk, HipChat, one of the popular chat service as well. It's about the getting the feedback from the customer and also internal. So for example, your product owner, your stakeholders, they can also provide you feedback. And sometimes we do take feedback in a form of survey. So in that case, we can use SurveyMonkey or any surveying tool. So the whole idea is that whatever you're doing, you are taking the feedback every time, and it's a continuous process. Now, when we are actually talking about Agile, we are actually talking about these things. So the DevOps architecture. And this is actually kind of like go, side by side. It's not actually completely a requirement that if you are following DevOps or Agile, you have to go through this, but we say that this is actually much better if you go in this particular architecture. Can anyone name me, like what is actually here? Containers, right? And what we do with containers? We ship items. Like especially countries like us, Bangladesh, India or Nepal, we actually rely heavily on export. And in order to keep the integrity of the items and make sure like they are going in a, like for example, you are sending fruits, it doesn't become juices once it reach to Dhaka or somewhere. So we actually use these containers. Now, this particular concept actually became very popular recently. And whenever you are doing Agile or DevOps, they are kind of like being synonymous. So we like the container technology. And what we do, we create little containers and deploy them. And what it does is that it gives us flexibility in many different ways. We can actually use same server for different services. We create microservice with help of container architecture. So we deploy different microservices in different containers. And we utilize our resources and make our life tougher. Because previously we used to have a one monolith service, one deployment, one server to manage. Now we have multiple. And then comes the most favorite one, the cloud computing. So we go and upload in the cloud, AWS, serverless, so many things. So there are Microsoft Azure is there, then Google Cloud is there, OpenStack is there. So what they do is that the whole this container concept, the microservice concept, they took it to next level. So what they do, they provide us managed service. So if you don't want to, get your hand dirty doing things or, crashing things, you might end up using them. So you need service, okay, go to Google, AWS and open up, say, 5 new servers. Few clicks, it's done. But if you want to do it yourself, then it might be a little bit problematic. Then we have container tools, like, for example, how many of you are using Docker in Nepal? Good. So that's kind of like if you are using microservice, at this moment, that's the default way to go. If you are not using Docker, then you might be a little, your life will be a little bit difficult to manage these microservices. So Docker is something we use, and if you're using Docker and you have hundreds of containers, how to actually you manage them? Then we use Kubernetes. So Kubernetes is actually for the orchestration. Like, what will happen? How many, say for example, you have 10 microservices, and each of the microservices have 5 containers. One of the containers is going down or taking more memory than it is actually supposed to have. Then what will happen is that you will kill the service and spawn a new service. You need a space. It will manage the space available from your server. So we usually don't want to do it manually. We love to actually orchestrate with Kubernetes. So it's pre-instructed, and it actually helps the containers to actually find the right balance between resource utilization and demand. So Kubernetes is something you can use, and if you are kind of like, not up to Docker, then you can go with LXC, the Linux container, the bare bone one. You have to do the hard work a little bit more than the usual but suggestion would be like go with Docker and Kubernetes. And if you are happy or want to be more adventurous, go with Apache Mesos. That's actually another tool. So these are actually all open source. Then we have virtualization. So for example, we seen the Docker. So if you are using Docker, virtualization is not required. But if you want to do virtualization, there are like VMware is there, Vagrant is there, VirtualBox is there. It depends on your need. Sometimes we don't want to use Docker, but use virtualization. So it's actually your choice which one you want to use. Then other DevOps tools, like we said that operate, continuously monitor. So what we do is that we'll keep log of everything. Now, how many of you have used Kibana here? Or Logstash, or Fluentd? So there are two popular stack we have, EFK and ELK. Elastic, Fluent, and Kibana, and Elastic, Logstash, and Kibana. So whatever you guys are actually using, Graylog, Logstash, Fluentd, you can actually use this for logging purposes. And logging is important because based on this log, we can actually see what is actually happening in the system. Then another hot cake in the market at this moment is BI or big data. BI and big data kind of like very much synonymous, especially big data. Like if you say that I'm a big data expert, people will be, hurrying to actually get you hired, whether they need it or not. So similarly, the BI tools that we use, especially this particular part of the world, we are more used to about Tableau. So though it's a paid product, but Tableau we actually use a lot for data visualization, and it's very easy to use. You have a data source, you can create your BI report in no times. So that's actually a paid product, but they have also a free tool. If you have Kibana, that's also free, but it's a very, you have to do a little bit of data pooling yourself. Then we have these security tools, another important part. If you are doing DevOps, now there's another term called DevOpsech. So development, operation, and security. So there are so many tools. Even for the security one, I can't actually maybe use 10 or 20 slides. That many tools are available. But there are some special tools. For example, Snort I used maybe 15 years back in Nmap. So these are the tools, very low-level tools where you can actually do so many things with them. But there are some other tools like evident.io. So those are actually full-fledged tools which you can use for security testing. Then process supervision. I don't know like how many of you are actually a DevOps guy who's dedicatedly managing lots of services. If you are actually running this, then maybe one of the tools that we use is Supervisor. So Supervisor does actually monitors what's happening inside our clusters and microservice architecture. If there is any alarm, for example, the database is actually taking more than 100% resource, it's allocated. Sometimes it happens, like big imports and everything. It can alert us like you need to actually fix it. Yesterday night, actually, I came up with this nice tool. So Xavier Labs actually created a periodic table with the DevOps tools. So I was actually more inclined to show you guys this than the whole presentation. So what they did, based on the different segment of work, say source control management, database automation, then also with the whole concept of open source, free, enterprise, they actually create a periodic table. And what they did, if you click on each of them, it will take you to a more detailed section where you can actually find about the software. So what I will do is that I will share the slide and I will share if you go to Xavier Labs, you can actually find it. It's xavierlabs.com. And I will share the URL where I found it, and it's really interesting, Not really. So for example, we have around 16 test tools. You don't need to know about 16 text tools, but you need to know for your particular use, and maybe I will modify it in down the line based on technology. So if you are using, say, LAMP technology, if you are using Java, if you are using .NET, we can filter out, So I just came to know about it yesterday night, and I was like, wow, that's something I should add in my slide. So we can filter out in different way. There are some missing pieces as well, so I am definitely going to work on that and make sure like it's a one particular way we can actually figure out what are the right tool set for us based on our project. Now, the DevOps practices that we should follow, that whatever you do, there are tons of tools, and it's very easy to actually get lost. And the most important part is that kind of like I feel bad is that, for example, we are working on a particular tools or technology. After 4 months or 6 months, it's gone. Teams come up with another tool, like it's much better, why don't you use it? So we have to invest a lot of time to actually learning new tools. Though they're doing same thing or maybe a little bit more, but the whole part of the configuration, the adaptation has to change. So the suggestion is that first you start with this version control for all, no matter whatever you're doing, use version control. Now you can say that I'm writing document, say requirement specs. How can I version control it? Any suggestion? Like what document? Wiki. Use wiki. Wiki itself is a version control. So use wiki. SharePoint is there. So these are sort of tools we should be using. Automated testing. Now, if we are following DevOps, this has to be there. So it's automated testing doesn't mean that we are only focusing on ATDD, like Selenium or Robot or API. So you should be actually focused more on unit testing, BDD-driven approach. So this has to be there. Proactive monitoring and matrices. So you should monitor your services and use some matrices. We'll go through the DevOps matrices that we actually use. Then Kanban or Scrum, whatever suits you. So we are not here to actually promote only Scrum. So if you are Agile, you can use any framework. And I always say that you can be Agile without using any framework. It's the mindset that's most important. Then visible ops and change management. Configuration management, we already talked about it. Then incident command system, like if something happens, who will take the control? Who will actually control the whole process? Put developers on call, that's also important. And that's actually the one point where most of the DevOps part have conflicts, that whether we should be actually giving the job to someone else called operations and developers will sit back. And if there is a problem, they will call us. It's the old thing. The previous, we used to call it system engineer. So DevOps is actually not that. And transparency in uptime and incident. So what happens is that if there is any problem, that the whole DevOps culture says that you should be transparent about it. You should not hide your incidents. Like 99.99% uptime. But actually uptime was 90%. So that's actually a bad thing. And the matrices that we use, there are tons of matrices, like deployment frequency, how frequently you are deploying, change volume, the deployment time, how much it takes, customer tickets, availability. The last two are more important, mean time to detection and mean time to recovery. So mean time to detection means that if there is a problem, what is the average time you take to actually detect it? And it happens is that sometimes the service is down, it's down for hours. After 1 hour, we are actually getting notified that it's actually down. So the mean time of detection is really high. And mean time to recovery is that whenever we found out there is an issue, how fast we can actually resolve it. And based on these two, actually, the whole DevOps practice changes, like how robust you are. Now, tricks for success. Any idea what is it? What are the tricks? No tricks at all. If you want to really want to be successful with your DevOps practices, there is no tricks. But the one thing, you have to get your hands dirty with practices. So define your workflow and pipelines, how you want to work. Try the tools that is suitable for you, not just others. So if I say that, okay, Jenkins is the best tool, move to Jenkins. Maybe you are using Team Foundation Server and you are actually, Travis CI that you are used to, and you heard that, okay, Jenkins is better, and it's going to save us $100 a year for us in the company, so move to Jenkins. And then you find lots of problems that, okay, Travis was much better. So these sort of things should not happen. Use whatever you are suitable with, that is based on your project and your preference. And last but not least, that is inspect and adapt. Then don't try DevOps but. So there is a Scrum but. Now we call it a DevOps but. So what is a DevOps but? that we try DevOps, but we have a separate team. How many of you have actually separate DevOps team? Me as well. And I've been talking to my CTO for the last 3 years that, I teach these things, different, conference, and I'm still having the same thing in my company, then what to do? So if you have a DevOps team at your organization, that's the first wrong thing you are doing with DevOps. It's not like, having a separate team to teach culture to Nepali people. That's the inherent thing. It will come from practice and beliefs. You just can't actually have people to actually enforce the culture. It doesn't come like that way. So I really hate the term called separate team. If you have a separate DevOps team, separate DevOps engineer, this is not working. So you are trying to actually make it work rather than definition of DevOps. So that's actually, I always say, and lots of the DevOps guys will actually not agree with me, but, So manual deployment and release, if you're still deploying manually and managing your releases manually, that's not happening. And just to give you like why I hate DevOps team. So what happens in my organization at this moment, we can't actually merge any pull request as a developer. So our right of merging has been taken. So they will merge it. And sometimes what happens is that we created a pull request, get the review done, all the QA verification is done, but that pull merge trigger is on DevOps team. And they are, enjoying their weekend, they will not merge it. And sometimes we have to ping them, did you merge it? No. When you are merging it, oh, you are busy with something, we'll merge it. So what happened is that one of the small fix that was needed within 5 minutes actually took, I think, 7 days. So we did it in 5 minutes. We fixed the issue. But after 7 days, it got released. And then my product owner came to me like, what's happened? It was a small fix. I was like, yeah, I gave it 7 days back. And there was guys like, oh, we didn't check whether it was verified or not by QA. So we are just waiting. So this sort of things actually happens because we are actually creating silos, the developers, the DevOps team. So that's actually a problem. And one of the bad news is that many big companies, like I travel USA a lot, and I talk with the good companies, like what they're following in their practices. And few of the guys told me like, oh, you are still with DevOps? That's gone. I said, what? So what is actually new? So that's actually my last slide. So there's nothing to laugh about, and that's quite serious. So in 2008, Google actually kind of like accidentally invented the term DevOps. Their practices came to, to public. So Google saw that there is always a problem where the dev and ops, when we are combining the culture, there is a conflict. Who will do the work? Whether devs doing the ops work or ops doing the dev work. So most of the time, it's shown developers are doing most of the ops work. And ops are actually kind of like relaxing and taking the credit. Oh, okay, we are managing everything. So what they did is, why not we do this? The developers will work little bit extra. So they call it a 50-50 rule. 50% time they will work on operations and scalability of the system. 50% time on development. So if they are not working on operation and scalability, they will work on development and vice versa. So in a sprint or in a particular project, they might have to work 100% on scalability and operations, less on development. And some cases, it might be 100% on development, not on scale and operations. The reason is that developers know what's best for their solution, how they want to scale it up, what are the tools they are using, what are the prerequisites, and they end up doing the work. So Google created this term called Site Reliability Engineering, SRE. That's actually kind of like hotcake in US market. So if you go there and tell them I'm a SRE specialist, they'll be more than happy. So DevOps for big organizations like Google, I talked with WeWork, then Apple is there. So they are more focused on SRE concept. So they ensure that, and the concept is very nice, that if your site is up, say for example, 99.999%, that's fine. We don't want to be 100%. The reason is that for this 0.001% improvement, the effort I have to give doesn't actually meet the expectation. The amount of work we have to do and the budget we have to spend, it doesn't make sense. And that particular 0.001% is not impacting my customers. So they are actually a nice concept about SRE. So since I am talking about DevOps for last 4 years in different conferences, so I decided to actually put a slide on that. The next time maybe I'll be talking about SRE, not about DevOps. So this is a new kid in the block. So keep an eye on it, and you will learn more about it. What they call is that DevOps is a particular way of doing SRE. So SRE, in terms of concept, is much bigger than DevOps. So thanks a lot. If you have any question, I would like to answer, but that's my presentation. And if you have any sort of question, welcome.